Washington University, and today we're going to learn how to graph sine and cosine functions. And before we start the process, I want to give you a little intuitive idea of what's going on and what you're actually doing. So let's take a look here at my circle that I've drawn over here on the computer. What I've done is, I know in the past you guys have talked about the unit circle, and I also know that you've talked a little bit about some right triangle trigonometry. So what I want to start with is just to show you the connection between the two and what we're going to be doing as we graph. You'll notice that my circle here that I've drawn is not the unit circle, and I did that on purpose to remind you that trigonometry is based on any circle, not just the unit circle. We tend to use the unit circle because then this radius or the hypotenuse of this triangle is 1, and that's convenient and makes problems easier, but I wanted to show you that it will work anyway. What I've done here is I've constructed this right triangle within my circle, and what we're going to be graphing when we graph the sine and cosine function is this angle right here in relation to that ratio between the, for example, for sine, the ratio between the length of this side here and the hypotenuse. Opposite over hypotenuse, remember, for sine. So you're going to actually be graphing along the x-axis the angle measure, say 20 degrees or pi over 4 or some measure. We're going to do it in radians. And then that relationship between the triangle side opposite over hypotenuse. And then of course for cosine we'll do the adjacent over the hypotenuse. But again, x-axis will be the angle, and then the y-axis when we graph these will be that sine or cosine function. All right, if you'll notice here I've got two dots plotted, and if you can see the colors, this guy up here is blue, and down here we've got green going on. This is actually the cosine, the point cosine for this particular triangle. It's the relationship of this angle to the cosine, and this guy down here is sine. Now what I want to do is I'm just going to move this around my circle and change that angle, and I want you to watch what's happening to those 2 points as I do that. Remind yourself though you're just recording that relationship. So as I move this angle around, let's stop up here at pi over 2. Okay, notice where your two values are at pi over 2. The cosine at pi over 2 has a value of 0, while the sine at pi over 2 has a value of 1. Now watch what happens as you continue around the circle. And let's see. As we hit pi right here, notice that we reversed. Our sine function now is at 0 and our cosine is at 1. All right, continuing all the way around the circle. This one's going to hop back over here instead of continuing. Just a glitch in my programming. And as we continue on, as we keep graphing, we see that they're going to repeat this pattern. Now, if you'll notice, before we get into this and learn how to graph it, if you'll notice, these two curves look very, very, very similar. In fact, if I could, I would pick up this curve right here, this cosine curve, slide it over, and it's going to mirror exactly that sine curve. So they're very, very similar. All right, so let's take time out now and let's see if we can figure out how we're going to graph these. All right, so today, of course, we're talking about trig functions. We're going to move over to the dot cam here, and to begin with, one of the best ways to begin this process is to graph by hand. Take time out and sit and plot it. And we're going to do one of the two. We're going to do sine, and then I'll leave cosine for you to do on your own. I've put the unit circle up here for convenience so we can quickly find our values. Remember, on the x-axis we're going to have our angle, and on the y-axis we'll actually have the sine. I've chosen convenient points to graph. Okay, these are points that you probably know well by now. The angle when it's 0, pi over 2, those kind of points. You really could do any that you wished, but these are kind of nice ones that go quickly. So at 0, this is the unit circle, so I know that my sine is the y value. So I'm just going to look at my coordinate and find the sine. So when the angle is 0 degrees or 0 radians, my sine is 0. At pi over 4, my sine is square root of 2 over 2. At pi over 2, sine is 1. 3 pi over 4, my sine is square root of 2 over 2. At pi, 0. 5 pi over 4, negative square root of 2 over 2. 3 pi over 2, there's my sine. Remember y value, negative 1. 7 pi over 4, negative square root of 2 over 2. Back around to 2 pi, we're back to 0, and then you can see what's going to happen. Once we get here, we're just repeating those same values over and over again. So we'll do a couple just to remind you that. So at 9 pi over 4, we're back at pi over 4 as our reference angle. Square root of 2 over 2. And then up here to 5 pi over 2 is going to be 1. All right, so once you get those values, we can go ahead and plot them on our xy axis. All right. Plotting those values, we're going to do a quick sketch. When the angle is 0, the sine is 0. At pi over 4, we've got this funny looking number, but if we go ahead and use our calculators and figure that out, it's approximately 0.7. So we're going to graph up here at 0.7 approximately. Then at pi over 2, we've got 1. Now again, notice you guys, the x-axis has been divided evenly into my radians. And how do I do that real quick? My first choice was pi over 4, and then all you have to do is count. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, etc. So when you're graphing, just start with your first unit and then just count from there. All right, 3 pi over 4 is 0.7 again. Pi is at 0. 5 pi over 4 is at negative 0.7. So we're going down here now, approximately. 3 pi over 2 is down at negative 1. 7 pi over 4 is at negative 0.7. 2 pi, we're back to 0. And then like we saw on our circle, it's just going to repeat the process. So this again is 0.7. And we went up here to 1. And of course it would continue forever in this pattern. Now I'm going to quickly sketch it to give you a feel and see if it doesn't look like our green wave did on that initial part that I showed you. Okay, so we've got this nice sine curve. All right, let me come back over here and give you a couple of definitions that you might be interested in. All right, a periodic function, our sine function behaves in what we call, has a periodic behavior. In other words, since it repeats itself and the length between the repetitions is constant, we call this function periodic. Okay, again, because it repeats over and over again in that same wave pattern, it's periodic. Functions that exhibit this kind of behavior, where they repeat themselves over and over again, and where they vary between two extremes, if you notice there was a high point on that sine wave and a low point, we call those cyclic functions. All right, so we're going to be talking today about two cyclic functions, the sine curve and the cosine curve. Now, if you would like at this point, it might be a good time to stop the video and hand graph the cosine function just to see its behavior. If not, you can stay with me and I'm just going to kind of give you a shortcut and show you what it looks like. So here we've got the sine and cosine functions. And let me change that up so we don't have that. See if I can. There we go. Let's go ahead here so you're not having to look at that background. So sine and cosine, if you'll notice, like we noticed before, they have the same behavior. The only thing that's different, if you'll notice here at 0, 0, you're going to see that the sine function crosses at the origin, while the cosine is at 0, 1. So it's just shifted over slightly, but again, the behavior is the same. Notice also, you guys, in this picture, that your highest point on both the sine and cosine function is 1. Now think about that unit circle. How does that relate? All right, and the lowest point is a -1. Again, think about that unit circle. How does that relate to this function? So I have my two extreme values. My high is 1, my low is -1, and it's repeating itself, so this is definitely what we refer to as a cyclic function. All right, so let's take a look at some of the characteristics of a cyclic function. All right, so one thing that we have is something called amplitude. So I'm going to go back over here to the computer. And let me give you the definition of amplitude, and then we'll take a look at some. All right, amplitude defines the height of the graph above the horizontal. Now, I was careful not to put the word horizontal axis, because sometimes that y-axis or that x-axis is going to move. You're going to actually shift these graphs up and down, so we're going to think of it in just terms of some horizontal line in which the graph splits the graph in half. So amplitude is how high above that line your graph goes, or how far below. I tend to like to think of the maximum part. All right, so in the function f of x equals a sine of bx minus c plus d. This is what we call a sinusoidal function. In this function, that number a that's in front of sine or cosine is going to be the amplitude. You take the absolute value of that number a and you've got your height. To calculate it, and we'll see this in just a second, we can take the maximum value, the maximum height, minus the minimum height, and divide it in half, because that's where that line is going to fall. Now I want to just point out something real quick that we'll deal with later on. If a happens to be negative, when we go to graph it, what that's going to do to your function is just reflect it across the x-axis, reflect it over the horizontal, and we'll deal with that a little later on. But a could be positive or it might be negative. All right, let's take a look at, over here, let's look at a picture on our dot cam of a graph and see if we can't figure out the amplitude here. All right, for a lot of graphs, you can simply look and say, well, how high above the horizontal is my graph? But we're going to go ahead, because some are a little more complicated, we're going to go ahead and calculate it anyway. This one I think most of you could see. The horizontal falls on the axis this time. That's where my graph is split in between the concave down and the concave up wave. The distance from that line to the maximum point is my amplitude. So I'm trying to figure out how high above the graph that lies. All right, I can clearly see it's 2, but let's say I couldn't tell that. How could I calculate it? My amplitude is equal to the height of the maximum value, which is 2, minus the minimum, which is -2, and I want half of that, because I'm only talking about half of the curve. All right, so that would be 2 minus -2 is 4 over 2, amplitude is 2. All right, so one part of this function that we're going to need to write sinusoidal functions, of course, is amplitude. A second part, let me give you another definition. Another thing that you need to know and understand over here at the computer is frequency. The frequency of a sinusoidal function represents the number of times a cycle repeats within the interval 2 pi. If you notice that our graph originally started repeating after we got all the way around the circle at 2 pi, then it started over again. The frequency represents how many times that cycle, that up and down motion, happened within an interval of 2 pi. Okay? In our function, our sinusoidal function, the number b, which is the coefficient of your x value, which is found right after sine, will represent the frequency of the function. All right? So let's again take a look at a problem and see if we can determine frequency back here over here at the dot cam. Okay, here's an example of a cosine function. All right, and again, why not, while we're here, why don't we figure out the amplitude as well? So let's go ahead and do amplitude first. The height above that horizontal, which again is the axis, and I promise I'll show you some that aren't in a minute. So how high does this go? Well, if you can read this graph, here's 10, 11, 12. So my amplitude is 12 units above the horizontal. All right, if again you need to calculate, you could do 12 minus negative 12 divided by 2. All right, frequency is how many complete cycles do we get through before we get to 2 pi. Now we're going to do this the easy way first by just looking, and then in a minute I'll show you a way to calculate it. So here is one complete cycle. From maximum point to maximum point, there's one cycle of the cosine function. If I go again, by the time I get to 2 pi, I have completed 2 full cycles. So my frequency for this particular graph is 2. Okay, and again, we'll talk about how to calculate that in just a minute. I want to give you one more definition. So let's go back one more time and let me give you that. Something very closely related to frequency is period. The period of the sine or cosine function is the distance it takes to complete one full cycle. Frequency counts how many cycles, okay, how many cycles occur between 0 and 2 pi. The period is, well, how far did it take to get through one of those cycles, okay? In our function, our sinusoidal function again, the period of the sine function is found by simply dividing 2 pi by your frequency. So that'll tell you how long it takes to complete one full cycle. All right, so let's take a look at another problem. And let's calculate the frequency, the period, and the amplitude for this graph. All right, so first thing, let's start with amplitude. And let's see if we can figure that one out, either by looking or again by calculating. And I think this one again, because I've got my horizontal as my axis, it's easy to see. As we shift that axis in our next lesson, we'll see how to calculate. But for now, I think we can see that it appears that that amplitude is approximately 3. All right, next we need to calculate the frequency and the period. All right, let's remind ourselves what we just read. The period is equal to 2 pi divided by the frequency b. All right, so in this case, I think it's actually easier to see on this sine function to see the period, and then we'll calculate frequency from that. Sometimes it's easier to get the frequency and calculate period, but you can go back and forth with it. I know this is a little bit hard to read, but it looks like I completed a full cycle. This time I'm looking at the intercepts from 0 to, this is pi over 2 right here. Okay, that's a half a pi right there is what that says. So from 0 to pi over 2, I complete a full cycle. So that's my period. Pi over 2 is the period. So let's go ahead and write that down. And to get the frequency, I know that period is equal to 2 pi over b. I simply have to solve this equation for b. So multiply both sides by b. Pi over 2b equals 2 pi. And then I need to divide both sides by pi over 2. So b is 2 pi divided by pi over 2, which looks like a nasty mess. But remember, I'm just simply dividing. So when you divide by a fraction, you may flip and multiply. b is 2 pi times 2 over pi. Cancel. My frequency is 4. And if you'll think about it for a minute, it makes sense. If I complete one cycle in half of a pi, it would take four cycles to get through to 2 pi. All right, now that we've got that, let's try to write an equation for our graph that we currently have. It is a sine function. So y equals, all right, amplitude will come first, 3. Then we want either sine or cosine function n. I'll give you a little heads up. Normally, since we saw that the cosine function is the sine function shifted, we usually just use sine. So that's something to know, but you can use cosine if you want to. All right, 3 sine. Now, the next part we said was going to be the frequency, which is 4, and then our variable x. And there you go. All right, the last thing we're going to do is give you an equation now and then have you graph it, okay? Instead of giving you the graph and having you write the equation. So let's take a minute out and look at a couple of these. All right, the first one we're going to look at is f of x is equal to 3 cosine 2x. Again, before you start, pull out those 3 pieces of information that we need. Amplitude. Well, amplitude, remember, is found in front of the trig function. So my amplitude is 3. When you're given an equation, you can find the frequency much easier than the period. So start there. Frequency will be after the trig function in front of the x. So my frequency is 2. And from that, you can get the period. The period is 2 pi divided by the frequency. So in this case, my period is pi. All right, we don't want to have to hand graph and plot points anymore. So I'm going to show you some techniques that you can get to graph a trig function without having to do that. It's all in the way that you label your x-axis and your y-axis. So what we want to do is we want to find out a convenient increment in which I can go up by on my x-axis. 0 is always a good place to start, so that's where I have it. And what we're going to do is we're going to complete one full cycle. So I'm going to call these my increments. All right, what is my increment? Well, the points that I need in order to sketch a graph of this, I need the maximums, the minimums, and the x-intercepts. I need to know where it crosses. And if you think about the wave, as you go from here, you hit one maximum, one intercept, one minimum, and then back to the intercept. So there are actually 5 points, including 0, 0, that I need. So how can I figure out my increment? What you can do is you can take your period, because that's one complete cycle, and divide it by 4. And what that's going to do is that's going to give me 2 complete cycles, so I can see what's happening here. If you want just one complete cycle, you could take half of that. All right, so what we're going to do here is we're going to go up by pi over 4 because I want to. I'm going to start here and just start counting. 0, pi over 4, 2 pi over 4, which I can reduce to pi over 2, 3 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is 2 pi. Okay, that'll give me 2 complete cycles. All right, my amplitude is 3, so I have to be sure that I can get up to 3 and down below the horizontal to -3. All right, then this is where your intuition comes into play. You have to know the parent function that you're dealing with. When you deal with cosine, you have to remind yourself, where does it start? Well, at 0, it's going to be up here at 3. Okay, whereas the sine function starts down here at 0, 0. So you have to know what's going to happen. All right, the first value you come to is going to be your intercept. That's where it's going to cross. The second one will be the minimum, x-intercept, maximum. Okay, and if you'll notice, I'll go ahead and connect these guys as best I can. That's one complete cycle that occurred in pi. I like to see 2, so I'm going to keep going. So come back down, intercept, minimum, intercept, maximum. And there's my second complete cycle. All right, one final graph and then we'll call it a day. We're going to take a look at what happens when we throw a negative in front. All right, same process. We need our pieces of information first. Our amplitude, remember, is the absolute value of the number in front, so absolute value of -2 is 2. Frequency is the number in front of x, so it's just pi. And then my period is 2 pi divided by my frequency, which in this case is pi. So my period is 2. All right, to find my increments, I'm going to take my period and divide it by 4. So I'm going to graph these in halves. My x-axis will be divided into halves. So again, just start labeling by counting. 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, which is 3, 7 halves, 8 halves. And then that should complete 2 full cycles. Pay attention to what you're graphing. I'm graphing sine, but I got this negative. So what I'm going to do is I'm going to ignore the negative for a minute. I'm just going to graph it as if it were 2 sine of pi x instead of -2. But I'm going to do a really light sketch for that function. So if I were graphing it without thinking about the negative, sine starts at 0, 0. We go up to the maximum first, and I'm going up to 2. Back down to the intercept, go down to your minimum to -2, intercept, up to 2, intercept, -2, and back. Now I'm going to lightly sketch this. And I can see that I have 2 complete cycles, and in fact, finish it out, 2 complete cycles. All right, the negative, if you'll remember from your previous classes, the negative in front is going to reflect this function across the x-axis. It's going to flip it over x. So all that's going to happen when you do this is you're going to reverse your max and min points. In the parent function for sine, you go to the maximum first. When it's negative, you're going to go down to the minimum. So this time I'm going to switch those maximum and minimums, and then I will draw my final function. And you can do it either way. You can either lightly sketch it and then flip, or you can think about it from the beginning. So my graph for this function is going to look like that. All right, in addition to these 3 things, we're going to learn some more things tomorrow about how to graph, but for now this is enough to deal with. I wish you good luck on these, and I'll see you tomorrow.